This how-to video is about displacement reactions involving Group VII halogens. And basically what we have, or what we know, is that a more reactive halogen, a halogen which is higher in the group, will effectively displace a less reactive halogen from a solution of its compounds. And here's an example, typical example. If we take chlorine water, which contains chlorine element, and we add it to a solution of sodium bromide, what will actually happen is the chlorine will replace the bromide. So the chlorine will become chloride and the bromide will become bromine. And this is actually an oxidation and reduction reaction. So essentially this is what's happening. The chlorine water is put into sodium bromide solution, and sodium chloride is formed and bromine is released. And just looking at it in terms of what's actually happening at the electron level, is that the chlorine is gaining electrons. It's actually gaining electrons from the bromine. So the chlorine goes from an oxidation state of 0 to -1. So it's gaining electrons, it's being reduced itself, so it's the oxidizing agent. In other words, chlorine will oxidize the bromide to form chloride and bromine. And the best way of showing that is via a little experiment. So let's have a look at this. So here is our sodium bromide solution, and we put this into a boiling tube. You can see it's a colourless solution. Now, what we now do is we add some chlorine water. Chlorine water effectively contains chlorine element. If we pour that in, just watch what happens to the solution. You can see that it starts to turn a sort of orangey brown colour, and that is because the chlorine has displaced the bromide. So the chlorine has become chloride and the bromide has become bromine. And to show that better, what we do is we add a non-polar solvent. In this case, a non-polar solvent is cyclohexane, often used in this type of experiment. And it's a non-polar solvent, and because bromine is non-polar, what will happen is the bromine, if we shake this solution together, will actually dissolve in the non-polar solvent. So we'll come out of the solution at the bottom and we'll actually form a layer, and you can see that layer on the top. Here we have the layer on the top. So this is the cyclohexane, and the bromine, which was in the solution, has dissolved in the cyclohexane. You can see the bromine is an orange colour. So the chlorine has become chloride in here, so we have sodium chloride, and the bromide has become bromine, and that's dissolved in the organic solvent, the cyclohexane. And this tube over here is actually the same experiment, but instead of starting with sodium bromide, what I've started with is with sodium iodide, and exactly the same will happen. Chlorine, being more reactive, will displace iodide, so we end up with, again, with a sodium chloride solution in here, but the iodide will now become iodine, and the iodine will then dissolve in the organic solvent on the top, and you can see it's a very deep purple here. If we keep shaking the tube, all this red colour will eventually go into the organic solvent which is on the top, and likewise if we keep shaking this solution, all the orange colour will go into the organic layer on the top. So that's displacement reactions. It will not work the other way around. In other words, if I do this, if I put bromine into sodium chloride, that reaction will not happen. So in this example you can see bromine, sodium chloride. Bromine is not as reactive as chlorine, it's lower in the group, so it will not displace chloride from a solution of sodium chloride. So this is a no reaction. If we follow this through then with all of the solutions, so here we have chlorine added to sodium chloride, chlorine added to sodium bromide, and chlorine added to sodium iodide, you'll see the results of the experiment more graphically formed. Okay, so in this case nothing. Chlorine will not replace chlorine because it's the same reactivity. Bromine, chlorine replaces the bromide to make to liberate bromine, which is in the organic layer that we've just talked about, and the same with the iodine and the iodide. Chlorine water into sodium iodide liberates iodine, and the iodine dissolves in the organic layer, and that's what gives it the purple colour. So I hope that helps. Thanks.